Good morning, everybody. I hope you did well yesterday and everything we learned and continuing to do so. Before we start with today, we're going to be focusing on intersecting linear models, just a little uh, expansion on what we've been doing with linear equations from word problems and stuff. So last time, in case you didn't see the games, Brewers beat the Cardinals 6-0. Wonderful. Cubbies beat the Indians 3-2. As per usual, we continue to win. Cardinals continue to lose. So brings me to today. So I had a little fun with someone in particular yesterday, and probably for the rest of the school year. But just made this up, had a little fun, just to really. This looks a lot like what you're going to be seeing today on your own for the group work on problem 2.5. Here's how we do this. I got this information here, and yes, they're big numbers, but again, trust the process. Don't worry about the numbers, just follow the process. It's always the same. We're going to answer these questions. What equation models each situation? What probability would have 7,000 people in attendance at both? What's the attendance at both with 50% chance of rain? And what probability of rain gives both the same attendance? Now, one thing I want you to remember is the book doesn't always ask this question first. For some reason, it sometimes asks the question last. What equation models the situation? What I want you guys to start doing is developing those habits of mind. Always create those equations first. It makes things run more efficiently, you're more accurate, and it doesn't take as long to get through a problem. So first things first, remember, we're always going to be putting equations into slope-intercept form, and I think you're getting better now with the terminology, vocabulary. We know this is our rate, slope, constant of change, rate and slope. This is our constant or our y-intercept or our initial phi. We're learning a lot of different problems and we're seeing a lot of different stuff. I want to make sure you guys understand all the different vocabularies that relate to the exact same pieces of the equation. And we got to remember that slope is equal to the change in y over the change in x, which is the same as rate. So here's how we do this. We're looking at our information, probability of rain, Cubs attendance, St. Louis Cardinals attendance. I can see that the rain is the independent variable and the attendance is the dependent variable because the attendance is changing when the rain changes. So if you want to, for a habit of mind, give this your x, this is your y1 and your y2. There's two, I say y2 not like the y2 of, doing slope. I mean, this is one piece of information related to this. This is the other piece of information related to this. So that's where you're going to see that. I'm just creating some more room right here. So here's how we're going to do this. We're going to find the equation for the Cubs, then we're going to find the equation for the Cardinals. So we already know the y-intercept for both of them, and I can see that the Cubs have a low attendance for 0 chance of rain. Clearly you can see the Cubs fans like going to the game as rain increases. Maybe they have more fun. Who knows? I made this up. It's just to tie in with today's lesson. Whereas the Cardinals' attendance is dropping the minute rain starts falling on their pretty little heads. So let's do Cubs first. First things first, I want to find that change in y over the change in x. I know it's increasing, but I want to find out how much. So I'm just going to quickly do my change in y, and I'm going to make sure it's consistent. And give me a second. And I'm just going to make sure that I do this. This is how you can always figure out what the change is by doing this fast. 3,600 minus 2,000 is obviously 1,600. And double check that 5,200 minus 3,600, well, that's also 1,600. So I'm going to have your change in y is it's going up by 1,600 as x is increasing by 20s every time. So my slope is going to be 80. Okay? So my equation for this guy right here is going to be y equals 80x, and my slope or my y-intercept is plus 2,000. Okay? Remember, my difference in my y is going up by 1,600 every single time, and I divide that by my change in x, which is going up by 20s every time. Now let's do my cardinals. Okay? I'm going to do 11,000. I'm going to do 11,360. 11,360. Sorry, we know it's a minus. We know it's a negative. 11,360 minus 13,160, and we get 1,800. And then double check that again. Do this minus this. I'm sorry, it's a negative 1,800. And then we get another negative 1,800. So it's negative 1,800 over 20, and this is equal to negative 90. So, and this is true because it's going down, so this has to be negative, okay? Now, continue on. Let's make the equation for this guy, and we'll put him right over here, just so we have it all in an organized place. I know that this equation is y equals negative 90x plus 13,160. There you go for that. Now that we got our equations made, now we can answer these questions much more efficiently. So let's go for it. What probability would have 7,000 people in attendance? So my y is my attendance, my x is my probability. So you got to remember, you always ask yourself, what letter do I know? I know 7,000 people, I know my y. So we're going to literally answer both by doing this. Equals 80x plus 2,000. And to solve for x, just subtract 2,000 from both, because opposite sides of like terms, opposite operations. I have 80x equals 5,000. Last but not least, I divide this 80 out on both. And when I do 5,000 divided by 80, I get 62.5. 62.5 for this one, for the Cubs. And now let's just right next to it, let's do the Cardinals. So right here, I know it's 7,000 equals negative 90x plus 13,160. I subtract 13,160. Subtract 13,160. And when I do 7,000 minus 13,160, I get negative 6,160, which is nice because I'm going to do a negative divided by negative, which will make a positive answer. And I'm going to divide that by 90, and I'm going to get x equals 68.4. Well, it repeats, but that's why it's estimated this way. It's good enough. So that's how we do that one right there for the second question. You guys can pause right there, take some notes, ask me questions during whole group today. Going on, let's do the next one. The question now says, what's the attendance at both with 50% chance of rain? Well, what letter do we know? Now we know the x. So, very simple. Y equals 80 times 50 plus 2,000. And right next to it, I'll do this one. Y equals negative 90 times 50 plus 13,160. Well, do our math. 80 times 50 is 4,000 plus 2,000. Y equals 6,000. 90 times 50 is negative 4,500 plus 13,160. Well, let's do this. What is 13,160 minus 4,500? So our attendance is 8,660. There you go for that. Just replace the letters we know with the numbers we're given and solve. Last but not least, you're going to be seeing questions just like this in today's work. So it's the same process, different numbers. Follow and trust the process. Last but not least says, what probability of rain gives both the same attendance? both the same attendance. I want to know when they are equal to each other. So I have both equations. The beautiful thing is now I just set these equations equal to each other when asked a question like this, and I solve for x. 90x plus 13,160, and we're going to solve this answer. So I'm going to add 90x because it's negative to this 80x over here, and at the same time I'm going to bring this guy over to this side because these are like terms. Minus 2,000, okay? On this side, I'm going to be left with 170x. On this side, I'll be left with 11,160. Last but not least, I divide both sides by 170. So let's see what answer this yields us. So 11,160 divided by 170, and I get a decimal answer, but 65.65, and that's rounded. That's good enough. This is about the chance of rain where both stadiums are going to have the same in attendance. This looks just like today's assignment, whole group work. So make sure you guys take notes, ask questions. Also review this week's and last week's YouTube clips to review for tomorrow's quiz on slope, equations of line from points, equations of line from a graph, so on and so forth. I'll see you guys in class.